Good morning. So let us start a new lesson about complex numbers. One thing we want to talk about is the modulus or absolute value of a complex number. Of course, the notion of absolute value should be familiar to you from the real numbers. Yes, it is the magnitude of the number, regardless of the sign of the number. For example, if I have 5, if I ask you what is the absolute value of 5, the answer is 5. Yes. And even if I ask you what's the absolute value of -5, the answer is still 5. Yeah, so that's the magnitude of the number. Yes? And then, of course, you already know that the absolute value of 0 is also 0. We want to talk a little bit, we want to introduce the notion of absolute value, or in the context of complex numbers, sometimes we call it the modulus of a complex number. Yes? So if I have a complex number z, in the standard form, so let me write x this time instead of a and b all the time. Let me write x plus y, I. This is my complex number. This is the real part. This is the imaginary part. When I say absolute value of the complex number or the modulus of the complex number, I still denote it with the same symbol, but what I mean by definition is the square root of x squared plus y squared. So in other words, this is definition, so I can put semicolon equals to. So this is the definition of the absolute value of a complex number. So the absolute value of a complex number is equal to the square root of the real part of that complex number squared plus the imaginary part of that complex number squared. So that's the definition of the absolute value of a complex number. For example, so in order to find the absolute value of a complex number, you have to write it in the standard form so that you can recognize what the real part is, what the imaginary part is, put these numbers here, and you get a number. That number is called the modulus or the absolute value of the complex number. For example, if I have z equals to 3 plus 4i, if I ask you what is the absolute value of this complex number, the absolute value of this complex number is the square root of the real part squared plus the imaginary part squared. And then you calculate it. So it becomes square root of, this is 9, this is 16, and is it mine? Okay, no. So this becomes square root of 25. And then it becomes what? 5. So the absolute value of this complex number is just simply 5. So what type of number is the absolute value? First of all, even though I start with a complex number in general, the absolute value is a real number because I am taking the real part and imaginary part and square them. And one more thing is that this number is always non-negative. Okay, so absolute value of any complex number is a non-negative real number. Yes. But then one good point is that this definition is consistent with the older definition there. For example, if I say what is absolute value of this complex number, this number is real, but I told you every real number is a complex number. So what is the absolute value of this complex number? If you want to follow this definition, what is your intuition about that? If I want to have the consistency, I should get 5 back again. Yes, and I will. Why? Because 5 can be viewed as 5 plus 0i. And when I say what is the absolute value of this complex number in this new setup, it becomes a square root of 5 to the power of 2 plus 0 to the power of 2. And then it becomes a square root of 25. Still you get 5. Okay, so this is why you really don't need to do this calculation if your complex number is a real number. What you have in mind about the absolute value of real numbers still work here. So, but the point is that it doesn't matter if you want to follow the new definition or if you want to follow the old definition for real numbers. The answers are the same, and that is good because we want to have a consistent theory. Yes. Any questions so far? Okay, so for example, if I give you this complex number, 3, let us write minus 3i. So if I ask you what is the absolute value of this complex number, so you need to write it in a standard form first, so it becomes 0 plus minus 3i. You don't have to write this, I'm just writing it so that you understand. So this is the real part, and that is the imaginary part. So if I ask you what is the absolute value of z, it becomes square root of the real part squared plus the imaginary part squared. But this becomes 0, and this becomes 9, it becomes square root of 9, and that is only 3. That's the absolute value. So for example, what about this number? Minus a half minus a square root of 3 over 2 times I. Okay, I want to wait for you. It's a very simple exercise, but please do it. We want to find the absolute value of this complex number, yes? Okay, what the answer is? 1. Yes, the answer is 1. So if you want to calculate the absolute value of any complex number, first you have to put in a standard form. This is already in a standard form. So you take a square root of, and then you find the real part, which is this one, and square it. And then you find the real part. Again, I am emphasizing the real part is just this number without I. It becomes plus minus the square root of 3 over 2 to the power of. And then you have to calculate this. So this one becomes 1 over 4. This one becomes 3 over 4. So the answer becomes 4 over 4, which is the square root of 1, and that is also. So the absolute value of this is 1. I have introduced the notion of absolute value without any motivations. We will understand that the absolute value carries the notion of distance in the complex numbers plane. We will study that later. But for the time being, let us just introduce a concept. We can imagine that this is the extension of the old absolute value notion we had. Okay. Okay, now let us try to write some properties. These properties are scattered in the book as exercises, but I will also put them as under a title of a theorem type. Yes, so it means that if you want to have a better knowledge of complex numbers for the future, it's better to know these things. But for this course, you just need to solve them. You don't need to remember them. So I want to talk about properties of this notion that we just introduced. First of all, do you remember what I told you about the conjugate? So if I give you a complex numbers like that, what is the conjugate with this symbol? Yes?
3 minus 4i.
3 minus 4i. You just change the imaginary part to its opposite. Yes? Okay, so what do you think will be in general the relation between the absolute value of a complex number and the absolute value of its conjugate? How they are related? Yes? They are equal. Yes? So this is the first thing. If I have the complex number z, if I take the absolute value of this, it doesn't matter. It becomes exactly equal to the absolute value of its conjugate. This is the first thing, yes? Why is that true? This you might find as an exercise in the book. So the absolute value of any complex number is equal to the absolute value absolute value of its conjugate. Why? If you want to prove this as an exercise, so you would say that let z be equal to a plus bi, then z bar becomes what? A minus bi. Okay, so what do I have now? Absolute value of z is the square root of a squared plus b squared. Absolute value of z bar is the square root of what? A squared plus minus b squared. But of course, because of power 2, this becomes exactly the same. Yes? So from these two, I can conclude that the absolute value of z is always equal to the absolute value of z bar. It was very simple. The second thing is a nice relation. I would recommend you to remember this. This might be a good idea to have this in mind. What do you think will happen if I multiply a number by its conjugate? A complex number by its conjugate. Now imagine it. This is the number, and this is the conjugate. You multiply them. What happens? Yes? A squared plus b squared. But how a squared plus b squared related to absolute value notion that we introduced today? A squared plus b squared is absolute value to the power of 2. Is that right? So this is always true, that this becomes absolute value of z to power 2. So I would say that this is a very important relation to have. If you multiply a complex number by its conjugate, it becomes the absolute value of that complex number squared. So this combination is always a non-negative real number. So remember that as well. Okay. But then there is another theorem. So this is this. So number 3. This is important, and it's a level 3 problem in the book. So I want to solve it. If I have two complex numbers, say z and w, I multiply them first and then take the absolute value. Yes? I want to see if this is the case if I take the absolute value first and then multiply. Yes? I want to see if that's the case. Do you remember this question? I told you in mathematics this is usually relevant, and that property is called linearity. Okay? So you want to see if this is the case. Before doing it, what is your intuition? Should it be right or wrong? I don't know how much you know about about absolute values in real numbers. If x and y are real numbers, do you think that xy absolute value is equal to absolute value of x times absolute value of y? I don't know if you have studied this when you were studying absolute value, but this is true when x and y are real. And now, if I grant this is true for absolute value of real numbers, what should be your intuition there?
That's true.
It should be true because I want to keep consistency somehow. Might be it is true. But of course, the proof is a little bit technical, so that's a level 3 problem in the book. They ask you to show for every pair of complex numbers z and w, absolute value of z times w is equal to the product of the absolute values. Okay, so how should I prove these things? We had something similar, do you remember, about conjugate. But for the conjugate, for the conjugate, this was correct. Let me review that. It was correct to write this. It was correct to write this. And it was correct to write this. And also correct to write this, of course, if w is not 0. Yes? Now we want to see that are these rules also valid when it comes to absolute value rather than the conjugate or not? The first thing is just try to understand this, okay? Okay, if you want, we can start in order. What is your opinion about the counterpart to this? Okay, so let us just do that first. What do I mean by this? Can you formulate it for me to see that if it is correct or not? If I want to write something similar for the first one, but for the absolute value, what should I write? Yes?
The absolute value of z plus w is equal to the absolute value of z.
Yes, that is the speculation. So what do you think about this? So absolute value of z plus w is equal to absolute value of z plus absolute value of w. So we want to ask if this is true or false. Okay, the reason I changed my mind is that I want to keep the same orders. This turns out to be false in general. it is not always true. So even though it was true for conjugates, it is not true for absolute values. So if I say it is false, then I expect you to bring a counterexample. Can you think a little bit about finding a counterexample, meaning that give me two complex numbers so that when I calculate the left-hand side for those numbers, it is not equal to this combination for the same complex numbers. And make the example simple, okay?
-2, 5.
Yeah, you're just making it too simple. Let us work in the work of complex numbers. So let me take z, for example, I don't know, 1 plus I, and w, for example, let me take it as just 2i, yes? Okay, so let us calculate z plus w. What is z plus w? Is 1 plus 3i. And if I ask you what is the absolute value of z plus w, what's the answer? The first one is square root of the real part squared, 1, the imaginary part squared, 9. So it's square root of 10. Yes? But now let us calculate absolute value of z plus absolute value of w. What happens? Absolute value of z is the square root of 1 plus 1. Absolute value of w is what? The square root of 0 plus 4. So this becomes the square root of 2, and this becomes 2. And then you see that these two numbers are not equal. Okay? So in general, the first rule, which was true for conjugation, it is not true for taking absolute values. And there is a nicer relation, and this turns out you can prove this. If we have time, we can go through it. Always the left-hand side is less than or equal to the right-hand side. Okay, and this is a famous inequality. This is called the triangle inequality. So remember this. You don't need to remember the formulas, but you need to remember that, okay, don't be so naive. Just say that because that rule was true for conjugation, this also might be true for absolute values. So this is not correct. But I just give you the information that if you want to know what is true, this is in general true. Sometimes it becomes equal. For example, if I choose z to be 2, w to be 3, then they become equal because z plus w becomes 5. Absolute value of 5 is 5. Absolute value of z is 2. Absolute value of 3 is 3. When I add them, it also becomes 5. So sometimes they become equal, but not in general. Okay. So for the minus sign, the same. Yeah. So you can show that this is not true if I want to go to absolute value. So the counterpart of this is what is written there, and that's a level 3 problem. We want to prove that yes, it is true. So how should I do that for these problems? You remember how I did this? The same ideal will also work here. So if I want to prove that absolute value of z times w is equal to that, what do you think? How do you start? What? So you introduce two complex numbers in general and then calculate the left and right to see if they match. So that is a very important trick and simple. You don't need to be creative here at all. Okay, so I'm proving number 3 as the exercise in the book. So I would say let z be equal to, for example, a plus bi, and w be equal to c plus di. Yes? So how should I do that now? I will start calculating absolute value of z times w. So absolute value of z times w is equal to absolute value. Z is this number, and c is that number. Okay, tell me what to do. What should I do now? This is my left-hand side. So how should I continue? Yes?
Multiply the brackets.
I have to multiply, yes? So I keep the absolute value sign. I multiply them. It becomes AC plus ADI, and then plus BCI, and then plus BDI squared. Yes, but I squared is what? I squared is -1. So I will combine this one with that one, so it becomes absolute value of AC minus BD combined together. And between these two, I factor an I. So this should be a very easy calculation for you by now. Okay, now if I ask you what is the absolute value of this complex number, in order to answer this question, you need the real part and you need the imaginary part. You have them. So what is the answer? The answer becomes the square root of this part to power 2 plus this part to power 2. Yes? And then I have to simplify this a little bit. So I have to square this one and square that one using Math2C squaring rule. Yes, the first one squared, 2 times the first one times the second one with negative sign. The second one squared. This is the expansion of the first term. The expansion of the second one is also similar, yes? This becomes plus a squared d squared plus 2 times the first one times the second one plus the second one squared. Can I simplify something? Yes?
2A, B, C, D.
Yeah, this and that are the same. They have written in a different order. A, C, B, D minus 2, A, C, B, D plus 2. So they are. Okay, and now what I do, I will take this one with this one and factor A squared out. I will take this one with that one and factor B squared out. You might say why this is useful. You will see why. Of course, I want to wait for you to see why. I factor an A squared here. It becomes C squared plus D squared. And then I factor a B squared here. What is left? D squared and C squared. So let me write it as C squared plus D squared. Yes? So what can I do now? Now you should see why it was useful to do this grouping. Anyone else? Yes?
Take A squared to be A. No. Actually, I don't know.
You need to factor this out. Yes? Because this is now a common factor. I pull it out again. Yes? So what happens? This becomes square root of C squared plus D squared. So I am pulling this out. Yes? So if you want, you can consider this a box. Then it becomes A squared box plus B squared box. I can pull out the box. Yes? So what is happening? The box multiplied by A squared plus B squared. Okay, then what? We can split it. For the product, the square root of a product can be split. Yes, so it becomes square root of, if you don't mind, let me write this one first, because multiplication doesn't matter. So it becomes square root of this one. Yes? And now if I ask you, is this combination familiar for this number? What is that? The absolute value of z. This combination that you see here is just exactly absolute value of z. And this combination that you see there is absolute value of w. So it becomes equal to what? Absolute value of z times absolute value of w, and that is exactly equal to the right-hand side. So I was able to show that the left-hand side is always equal to the right-hand side. Is that right? I don't know if this is the solution in the book or not. because I told you this is level 3 problem in part of the book. But can you see an alternative and much easier way to prove this? So I want you to tell me, how can I use number 2 to prove number 3? So I told you that number 2 is a very famous combination in complex numbers, okay? Exactly like in trigonometries, I told you sometimes there are some particular combinations in trigonometry that it is good to remember them. That is one of those combinations. Z bar is equal to absolute value of z squared. Can you tell me, how can I use that number 2 to prove number 3 with less algebra? And of course, your previous knowledge about conjugation. So let me give you a little bit of hint. So here, if I ask you what is absolute value of z, you will tell me it is the square root of z bar. So if I want to calculate absolute value of z, of course I can use this formula as the definition, but I can also use this fact that absolute value of z squared is this, so absolute value of z itself is the square root of this product. So absolute value of a complex number is also equal to the square root of the product of that number by its conjugate. Okay? I want to do something similar here. My goal is to calculate absolute value of z plus is z times w. So what do I do? Absolute value of z times w. Okay, I want to wait for you. What should I write? Absolute value of any complex number like z is equal to what?
Square root
The square root of
z bar.
no, don't jump. Yes, absolute value of z w multiplied by zw bar. Yes, is that understandable? So if I want to find if I want to find the absolute value of any complex number, I take that complex number, multiply it by the conjugate, and take square root. Yes? But let us see, how can I go forward? Can you tell me? I mean, this is very obvious now. So what is the next step? There are some rules on the board. I want to use it now. Which rule is that? You don't need to. Okay, what should I do? What should I do? Yes, this is the conjugate of a product. This is on the board here. Yes? So I can write as the conjugate of the first one times the conjugate of the second one. So I will write it as a square root of complex number z, complex number w, but I am allowed to split this into z bar and w bar. Yes or no? Okay, now what can I do? Isn't it obvious now? Yes? Yes, I take this one with that one because that's a product. So I will write it as square root of z bar, w bar. Yes? But absolute value of z is, so this can be written as and what is this? This is absolute value of z. What is this? This is absolute value of w. So, but of course, for this one, you have to remember those things. So that's why I'm saying that for you, might be this is a better option because you usually don't remember the formulas, okay? And those formulas are not in the formula sheet. But if you know them, you can prove them faster. Is that right? Okay. So let me give you an exercise. If you understood this, let me write this. This is, I would say, a hard question. Let z and W be complex numbers. Prove that so this I want you to prove, okay? I want to wait a little bit for you, okay? It's not very hard, but if you find the way, hopefully you can find you understand how to prove it. So I want to prove that absolute value of z plus w squared is absolute value of the first one squared plus the absolute value of the second one squared plus 2 times the real part of the first one multiplied by the conjugate of the second one. So this is what you want to prove. By the way, these exercises, I told you it is hard, but you don't need to be that much creative. Can you give me immediately what is your instinct about to prove this? So you might find it an efficient way or an inefficient way. But in principle, you should be able to do it without thinking. So for example, I consider this a complete proof. I call it inefficient. I can say that this is a proof, 100% correct, but this is more efficient. But what I'm saying is that in complex numbers, if you think, if you understand what I said so far, in principle, even the problem of hard isn't very creatively hard, you know. It might be lengthy, but in principle, you should be able to do it. For example, one method that comes to your mind immediately should be what? Yes?
Like the absolute value of z squared as
Yeah, taking this method. Yes? In principle, you say let z be this and w be this, and then you calculate the left-hand side, put it aside, calculate the right-hand side, put it aside, and then compare it. It might be lengthy, but it always works. So remember this trick. Whenever you don't know what to do in the complex number problems, at least do this part. Okay? But now if I want to do it in a more efficient way, I want to wait for you a little bit, okay? So if you think that you cannot be so creative to find a better way, I recommend you at least do this way. Yes? Even though this might be A-level question, this was A-level question, but the algebra was a little bit lengthy, but not complicated. Just normal multiplications, additions, things like that. The people who wants to do it in creative way, I am asking you to use number 2. Again, number 2 that I have written up there with a combination of probably different rules. Now this is not hard. For example, let us say this is a level 3 problem in the book. And if I want to design something new, I can also give you this as a level 3 problem. But the method is the same. So let us try to modify this. So what do you do? In my case, I started from the left-hand side. In the middle, I realized that I can continue and reach to the right-hand side. Sometimes the algebra becomes involved, and you don't know how to go from left to the right directly. But what you can do is to calculate the left-hand side and simplify it up to some point, and keep it, and then go to the right-hand side, simplify it up to some point, and then compare it. Okay, so let us see which one goes. I don't know which one is suitable here, but let us try to do the same thing. So let us solve this problem again in 2 different ways. So what should I do? The first thing that I want to calculate is the left-hand side. And what I write absolute value of z plus w. Z is this one, plus w. And then to the power of 2. Yes, this is what my goal. But if I want to add them, you shouldn't have problems at all here. Yes, I add a and c together and put them next to each other between these two. I factor an I. And then I take absolute value and a square. Okay, can you tell me what should I write now? Because this is not hard. As I told you before, a level 3 problem is a combination of a lot of simple problems. So what should I do now here? If this 2 was not there, what is the answer? Absolute value of any complex number is the square root of the first one squared plus the second one squared. But because I have 2, even this becomes simpler. Because I still don't know, I don't need that square root sign anymore, yes? Because that power of 2 will cancel that square root sign. So what should I write finally, everyone? What should I write in front? A plus c, the real part squared, plus b plus d squared. In principle, I should have a square root sign, but because of this power 2, that's it. So this is the left-hand side. Okay, I don't know which way you prefer. Do you prefer to continue, or do you want to go to the other side and start comparing? Yeah, let us expand. Okay, so what happens? This becomes the first one squared plus the second one is plus 2 times the first one times the second one plus the second one squared. And this one becomes the first one squared 2 times the first one times the second one plus the second one squared. But you need to look a little bit on the right-hand side, and see what is the good choice. What do you think I will do now? By having an eye on the right-hand side. So do you see, at least, it is not very evident now, but I can do something. I want to group them. In which way you group them, if your goal is to reach to the right side? Yes? In what way I should do that? Yes?
Isn't the real part 2AC?
No, we don't know about the real part. But not before that. Yes?
Group A squared
And b squared. Why this is good? Why a squared and b squared together is a good idea? Because a squared plus b squared is what? Is what? Is absolute value of z, but to power 2. And I want it, yes? So that's good. So what happens, I will try to group these two together. It becomes a squared plus b squared. And then, of course, then it becomes clear what to do next. I group c squared, d squared together. And then I don't know what to do with them. So I have to live with them. So at least I see a 2 here. It motivates me to factor a 2. This is the at least one, yes? So it becomes AC plus BD. Yes? And then what happens? Instead of this one, what I can write? I can write absolute value of z squared plus absolute value of w squared. Understandable? And I don't know what to do with this. Okay, at least I don't give up. And if there are 3 points, I got 1 point at least, or 2 points, I don't know. It's better than nothing, and it's very reasonable. So you started from the left side, you reach to this one, and then you want to continue. So then what is your goal? Because you want to show this is equal to the right-hand side, you already got what you want here, you already got what you want here, you already got 2. So the only duty is that to go to scratch paper and ask yourself, is it the case that this one is equal to that one? Yes? If that is the case, I am done. Agree with me or not? So you see, I started. So this is not hard. And the only reason I have to draw your attention to it, be conscious and be aware of why you couldn't solve the problem. There is nothing that I can help you with, okay? So anyway, how can I prove this one now? Is everything clear? So the only thing that I need to prove to continue is this part really equal to that part? Because if it is, I can take it off and put that one there and I am done. Okay? So how can I prove this one? Yes? We calculate as before. So my question is that now I start calculating real part of ZW bar. How? I need to calculate ZW bar first. So let me calculate ZW bar. So this becomes the real part of Z is A plus BI. W bar is C minus DI. Yes? And you know how to multiply because these are simple things, yes? I multiply, this becomes AC minus ADI plus BCI. And then this becomes minus BD, I squared. But I squared is minus 1, so it becomes plus B. Yes? So this becomes the real part, AC and BD together as usual. And between these two, I factor an I out. So what is the real part? The real part is this one. So we are done. Yes, so I was able to show that the real part, this part, is actually AC plus BD. I have a 2, so it becomes 2AC plus BD. So now I come back here, and I would write this is absolute value of Z squared plus absolute value of W squared. But instead of this, I would write 2 times the real part of Z and W1. Yes? Is that understandable? So it was not hard again. I would say that this is comparable to the problem in the book. It was not in a completely different level. Yes? But if you want to do it, this is my advice for you, because usually you don't remember those formulas in your head, but this doesn't need any formulas. You just need to start. But if you remember some of these formulas, so do you have an alternative? Do you remember what ChatGPT guided us through? Did you understand its actually explanations? Yes?
It said we could write the left-hand side as Z plus W times Z plus W bar.
Yes, and that is, you don't need ChatGPT for that, because I told you here, if you want a complex number absolute value squared, you can write that number multiplied by its conjugate. Yes, so what I will do, I start from the left-hand side. So the left-hand side is equal to absolute value of Z plus W squared, but according to what we know, it means I write my complex number and I multiply it by the conjugate of my complex number. Yes? But we remember a rule from conjugation. Can I split this conjugation? Yes. So I can write it as Z plus W times Z bar plus W bar. And then what can I do? I can start multiplying. So Z times Z bar. If you don't mind, let me write W bar first. And then there are 2 more terms. What are they? One of them is ZW bar. The other one is Z bar W, or W, yes. Yes? But what can I write for this part? It's on the board. Absolute value of Z squared. What can I write for this part? Absolute value of W squared. The tricky part is this one. Do you have any idea what to do with that? My claim is that the second term is the conjugate of the first term. Is that right or not? What do I mean? I mean Z W bar bar. What happens? I can write Z bar W bar bar. But what is W bar bar? Is W. So it becomes Z W Z bar W. So the second number is the conjugate of the first number. Yes? So this combination is something like this. Yes? Whatever this is, the second one is its conjugate. So I am adding 2 numbers, one the conjugate of the other. So that combination is famous in complex numbers. Do you remember? We had it last time. What is that? 2 times the real part of that number. So this combination is very famous in complex numbers. Whenever you see this, This is one of the exercises in the national exam and in the book. So this one plus that one is two real parts of the box. Yes or no? Okay, so this, I want you to understand that this, even though it is written as slightly ambiguous, but this is this combination. So if what can I write instead of this? I can write 2 times the real of the box, but this is my box, and that's the end of story. So I started from here and I reached there, so that is the right hand side. So that is more efficient way to do it. So, but I do not expect you to do this. Of course, if you do that, you will get the grades. But the reason that I'm not expecting you, because these formulas are not in the formula sheet, and during the exam, you might not have access to them in your memory. But this is something that you are expected to know. This is not hard. Any questions? No? Okay, so there are some exercises in the book. Let us try to review a little bit. So the notion of absolute value is also finished. And then you will see that why absolute value becomes important in the notion of complex numbers. I didn't motivate you that much why absolute value is good to know. But let us keep it like this and then try to solve some of the previous problems in the book. But mainly I want to wait for you, or at least I want to hear from you how to solve it. Okay. One exercise I found in the book is good, is we want to solve some equations. Did I solve some equations for you in which the answers are complex numbers? For example, like, x squared plus, say, 5x plus 7 equals to 0. Did I solve something like this? Okay, so if I haven't, let us do that, because that is one of the very simple exercises. This is actually a Math 2C lesson, but that part of Math 2C is eliminated by schoolwork yet, so you didn't study that one. We want to solve this equation. But I ask you to solve this equation on complex numbers. So today's lesson is finished, we are reviewing things. Okay, so this, we want to solve this on complex numbers. So how should I do that? You either use PQ formula or ABC formula. So to be consistent, let me just do it with ABC formula. So what I would write x is equal to minus b. The formula is minus b. You have it in the formula sheet as well. Okay, so this becomes minus b plus or minus the square root of this to power 2 is 25 minus this times 4 times this times that divided by 2 times that. Yes? So in Math 2C, you would stop here and say there are no solutions. Why? Because 25 minus 28 minus 3, the square root of minus 3 was not defined in the complex numbers, but on the real numbers, but in complex numbers, you have to continue. How? So you would write minus 5 plus or minus the square root of minus 3. The only point is that don't leave it like that. Technically speaking, this is not wrong, but you have to show that you want to involve I. Okay, so this part, square root of minus 3 can be viewed as square root of 3 times minus 1. And then you can split it as a square root of 3 times square root of minus 1. You don't even need to write them down. You just do it in your head, okay? But don't leave it like that. What is this one? I. So this becomes square root of 3, but I outside. So you have to show that you're respecting the notion of I here. So this becomes minus 5 plus or minus square root of 3i divided by 2. And if you want to write it in the standard form, you do division separately. Yes? So as simple as that. So I don't want to solve more of these type of problems because you are familiar with it. But I saw one exercise in the book. I don't know why they mention it as E-level question. Might be it deserves to be a C-level question, but let me solve that one. I don't want to solve it. I want to write it down, wait for you to solve it for me, okay? This is the question. We want to solve a quadratic equation, but the variable they have chosen naturally is z, okay? Minus 3iz, and then minus 2 equals to 0. This problem is problem 5136, part B. Okay? So before you start, I want to draw attention between the main difference between this one and that one. Of course, one difference is that letter X is replaced by letter Z, that's a minor change. But what is the important change here? In general, yes?
B is 3i.
What is specific about 3i? 3i is complex. So in the previous problem, you cannot recognize this is a complex number problem unless I mention solve it on complex numbers, yes? But this is crying out that I am a problem in complex numbers because one of the coefficients involve I. So in my problem, the coefficients are pure real numbers. Of course, every real number is an imaginary number, but here you can realize that one of the coefficients is really a complex number, okay? I want you to solve that. This is a E-level problem in the book. Could you solve it? Yeah, it is easy, yes? So you just use the formula. So what should I write? I write minus b. So here in this problem, a is 1, b is what? Minus 3i, and c is minus 2. And the formula is there. So I would say that z is equal to minus b, which is 3i, and then plus or minus b to the power of 2. Be patient to write it properly. And then minus 4 times a times c. Yeah, I would recommend you, especially in the exam, don't take any risks. And then divided by 2 times a. Okay, so 3i is nothing. I cannot do anything with that. So what is the answer to this? You can do it in your head. What's the answer? Minus 9. So even though this becomes 9, but because of I squared, it becomes minus 9. So it becomes plus or minus 9. What is the rest? Positive 8, because I have two negative signs multiplied, positive 8, and then I divide this by 2. But minus 9 plus 8 is minus 1. Square root of minus 1 is I. Simple as that. So, and then I will consider two cases. 3i plus I divided by 2, which is 4i divided by 2, which is 2i. And the other scenario is 3i minus I divided by 2, which is 2i divided by 2, which is I. So the answers are very simple. But that was a good problem, okay? You might face some of these problems in the exam, okay? Yes? Okay, let me write a hard one for you. So the same story, we want to solve an equation, but the equation is this: 2, 1 plus I z squared. And then I have minus 4 times 2 minus I z minus 5 minus 3i equals to 0. So let me double check because I have to adjust the numbers in an appropriate way. Yes, that's correct. Okay, so because we have to finish in 10 minutes, so let me start solving. It is not hard, it is lengthy. So you have to be careful about calculations. And because I see that these numbers are not very friendly, so I don't bother myself to write the formula. I just calculate this one. When I am relieved, I put it back in the formula. Okay, so what I do, I would say that A is this number, B is this number, and C is this number. Yes? So what I have to calculate first is B squared minus 4AC. I don't want to disturb myself with writing so many things in one formula. So B squared is this number squared. This number is 16, and this number becomes 2 minus I squared. And minus 4 times this number, which is minus 8, 1 plus I, times C. So C is this, if you don't mind, I take a minus sign out, this becomes positive, and both of them becomes positive. Yes? And now I have to calculate it. There's nothing I can do. So this is very straightforward. The first one is squared, 2 times the first one times the second one. The second one is squared, is I squared, but I squared is minus 1. And I have to multiply them. A very easy task. So it is 5 plus 3i, I times 5, but I times 3i is 3i squared, so it becomes minus 3. And then let me multiply, but before multiplication, 4 minus 1 is 3, times 16 is 48, 16 times minus 4 is minus 64i. 5 minus 3 is 2, times 8 is 16, and 3i plus 5i is 8i, multiplied by that is 64i. And then I have designed the numbers in a way that they are cancelled. If they are not cancelled, you are in trouble. Why? Because if I survived somehow, then I have to take the square root. But we haven't studied how to take square root of complex numbers yet. So I had to design them in a way that this I somehow cancels. And it is cancelled now. Here, what's the answer? 64. Yes, and then I put it in the formula. So z is equal to minus b. This is my b. I multiplied by minus sign. And then plus or minus the square root of 64 is very straightforward. And then divided by 2 times a, which is 4, 1 plus I. Yes? Okay, what can I do? I can factor a 4 out. It becomes 2 minus I, either plus or minus 2, divided by 4 times 1 plus I. Now this 4 and that 4 are cancelled. Then I have 2 options. I choose the positive one, it becomes 4 minus I divided by 1 plus I. I choose the negative one, this is cancelled, minus I over 1 plus I. So this is one root and this is another root. Okay? So it was not hard. Okay? You have to learn how to calculate more efficiently. Okay, of course, this is not the standard one. Might be they ask you like this. They ask you what are the real parts or what are the imaginary parts of that complex numbers. Okay. Or they can ask you about the absolute value. Let us do that last part as well. By the way, I forgot to add one more rule here. That is good that I remember that. This rule is also applicable for division. The proof is a little bit harder, but if you want, you can convince yourself, of course, W shouldn't be 0. You remember I was just listing that, but for some reason I forgot to write this as well. Okay, let us do this exercise here. If I ask you what is the absolute value of this one, it is good to have this formula. I don't expect you to have that formula in mind, but if you have that formula in mind, for example, what is the absolute value of this root? They might ask you what is the absolute value of the root, yes? So what can you do? So you can take the absolute value of the numerator divided by the absolute value of the denominator. But the absolute value of the denominator is a square root of 1 plus 1, 1 squared plus 1 squared, and this becomes a square root of 4 to power 2 minus 1 to power 2, so it becomes square root of 17, square root of 2. So they can ask different questions. They can ask you, okay, what is the real part of the root? What is the imaginary part of the root? So you know what to do with them. Yes? So this is also good to know that sometimes you are asked to solve an equation under complex numbers. Sometimes the coefficients are complex, so you already expect that the solution is under complex numbers. Sometimes the coefficients are not complex, but still the answers will be complex because under the square root sign you will face a minus sign. One last question. If I ask you what is the square root of minus 16, what do you say? 4i. Yeah, so this is, you know. Okay, so that's it. Any questions? Okay, so tomorrow, I don't know, the Math 5 students, we will have a quiz. And please bring your laptops. And just wait so that I stop recording.